Welcome to part 4. Hope everybody's doing well. In part 4, we're going to cover the problem that we found with our B+, but first we're going to just do a recap of what we did in part 3. If you recall, in part 3, we connected our radio up to a dim bulb tester and plugged it into our Variac. We brought it up slowly, and we watched that the bulb started to glow a little bit when we got up to about 110 volts. We also monitored our B+ through the meter, and we saw that our B+ was rising. And you also saw that when we brought our voltage all the way up, we saw an immediate brightness of the bulb and then a dip in the B+, and we shut things down. I can't stress the importance of using a dim bulb tester when you're working on these radios initially. That dim bulb tester saved our transformer in the radio. And once you understand what was wrong with the radio, why that B+ dove like that, you'll appreciate the fact that having that dim bulb there was the reason why this radio is still usable. So let's jump right in and talk about what happened. Okay, so typically what I would have done had I not been paying attention to this radio is after I had that problem with the B+, I would have taken the chassis, I would have replaced every electrolytic, which already has been done, every capacitor, and probably many of the resistors, thinking that's going to solve the problem. But in thinking back, does that really provide the root cause of what happened? Not really, right? The whole point of this hobby, when you have a problem and you fix it, you want to know how you fixed it, right? Because those things go into your long-term memory, and then the next time you have a problem, you think back and you go, oh yeah, when I had that problem, here's what I found. Let me check that again and save ourselves some time. So that's why it's important to find the root cause. Now, root cause is really simple. It's asking why until there's no more answers. So if you think about what happened with our radio, our B+ dipped. Why? We don't know. Let's take a look under the radio and find out. Okay, and then we go to the next step. So let me talk about what happened in our radio and what we've done to fix it, and then we'll be able to proceed with part 4. So the first thing that I decided I was going to do when I had the problem was do a visual inspection of the radio. And I looked again around the radio, and I looked at the rectifier socket underneath, and I found that between pins 1 and pin 8, I had a solder connection that was close to each other but not touching. If you remember in the last video, I said we probably have some arcing going on. Well, I think that's what happened. I think once we brought our voltage up to the 180 volt range, around there somewhere, that was enough to generate a spark that jumped across the two connections. That's exactly what was happening in our radio. So I took that little bridge that was there, and I cut it off, and now there's a very large space there. So then I took out the rectifier tube that was there, and I inspected it and said, okay, well, let's see what happened to the tube. Let's zoom in on this and you'll see exactly what happened. If you could see this right here, there's a hole right in here. There's a hole in the tube. That's pin 1 and pin 8. Pin 1 is our heater. I'm sorry, pin 8 is our heater and our cathode, and pin 1 is the tube shell. So we basically shorted this tube out. Okay? If I had put this tube back in the radio and powered it up, it wouldn't work. The tube's probably shot. I'm not going to take any chances. So by having that solder bridge in the radio, this tube is ruined. Now this tube was probably marginal to begin with, but the tube is no longer good and it needs to be thrown out. And that's what we're going to do. If you remember, this is a 5Z4, which we said is compatible with a 5Y3. If you remember that in episode 1, we determined that these tubes are interchangeable. So the next thing I did is I went through my tube stash. We're going to dump this out. I went through my tube stash, and I found a really good GE 5Y3W. Tested good. It's nice and clean. And I think this will be a perfect tube that we can use in this radio as a rectifier tube. So we are going to put this in the radio, and we're going to test our voltages and make sure everything looks good. So let's do that. So I want to talk about a discovery I just made, which I stopped the camera for because I had to check it out. So I found this tube. This is the tube that I used to test, and it says USN 5Y3 WGTB. Okay, that's cool. As I was recording the previous segment, I noticed that there's etching on the tube that says 6087. And I'm like, what the hell? All right, I remembered that it was not uncommon for manufacturers to reuse tube bases, and I thought, boy, did I put the wrong rectifier in this thing? Well, it turns out that this is a very high-end rectifier. You can buy a new one of these for about 50 bucks. They go on eBay for about $25. And this is a what is called a rugged full-wave rectifier 5Y3 tube. And I think it's denoted here USN. I'm pretty sure these are made for military use, US Navy. So we are not going to use this tube in this radio. This tube is too valuable to use in this radio. We have plenty of other rectifier tubes. So we're going to use this one here. I just have to clean it up a little bit, but it tests good. And this is a 5Y3 GT, and this should work just fine. So we're going to put this in the radio, like so. We've got our meter connected. We're not going to use the dim bulb tester here because we know that we've solved the problem. So we're going to bring up the variac, and we're going to go to 50 volts right there. Start there. Okay, our B plus is climbing up nicely. I expect this to go well over 300 before it comes down. Let's go to 80. There's 350. As those tubes start to conduct, you're going to see that drop. There it goes. I'm going to go to 100. You hear the radio come to life. Let's lower the volume. And you can hear we have a dirty volume pot. We're 240 at 100 volts. Let's bring it up to 117. And we are riding right at about 300 volts. Okay, I'm going to turn this down so I don't get a copyright hit, but just make note of that 300 volts. Okay, why is that 300 volts important? Let me explain. Take a look at our schematic. Let's zoom in on this so you can see it. You'll see right here off our rectifier, which is coming right here, up here. This comes off of our filter caps. You'll see that the radio is calling for 277 volts. Similarly, if you look here, coming right off of the rectifier, it's mentioning 277 volts here as well. Well, we're getting 300. Is that a problem? Not really, and I'll tell you why it's not a problem. If you look at the fine print right here, it says voltages should be held within 20% with 117 volt AC power supply. Okay? So if you take the 277 volts and the 300 volts that we're getting on the meter, it equates to about 8%. And I did the math just to prove it out. So it equates to about 8%. So we have an 8% differential in the radio, and that's because the line voltage is no longer 117. It's a little higher. So we are well within our spec on this radio, and we are in generally good shape here. Our power supply section is certified. We know that it works. I've let the radio run for about an hour with that with this tube installed. This is the expensive one. I'm going to do the same thing with this tube that I just put in, and I'm going to let that bake for a bit, just make sure we're good. Once that's good, we're on to the next step of our restoration. So let me stop this, and I'll come back and we'll begin where we are. Thanks. Alright, so the next thing we want to do here, we've tested our rectifier tube, it's working just fine. I let it run for about an hour. The next logical step here is we want to check all our voltages. We don't just say, okay, the radio's good, we're done. We don't know if the radio is healthy. We don't know if we have a condition in there that the tubes may be impacted, short life, that kind of thing. So we always want to do forensics and make sure we understand the health of this thing. This is kind of like having open heart surgery and then not testing your vitals afterwards. Just saying, okay, your surgery's done, go home. We don't want to do that. We want to make sure everything's good. Okay, we're going to check our voltages now underneath the radio, and there's a few things I want to make sure I cover. So typically at this point we know the radio works well. The power supply is good. So we're not going to want to do this on the Variac. And the reason why is if the Variac is not accurate or is not set correctly, your voltages are going to be different than the wall. So typically what I'll do is I'll plug the set into the wall, make sure that it works, of course, and that will be the line voltage that I use to check these settings. I also create this chart. So what I did was I took I drew a picture of the bottom of the chassis. Here's the transformer. Here's all my tubes. And we're going to zoom in so you can see what I've done here. This may be helpful for you. I identified each tube. I put where the key is. I identified the voltage that I'm expecting to see based on the schematic. And I also indicated which pin I'm going to check on. So I've done all this work beforehand, so when I get in here, I'm not going to be poking around looking for the right pin. One thing I want to mention on this radio as well is the schematic that I downloaded from Nostalgia Air makes it virtually impossible to read the voltages that I'm supposed to see. And I can show you evidence of that here on this chart. You can hardly read these voltages. Right here there's a voltage, here there's a voltage. It's very blurry. I don't know if that's 66 or 96, I'm not sure what it is. So typically when that happens, what I do is I go and do a search on Google and see if there's a service manual for the radio I'm working on. And in this case, I checked for a RCA radio service manual, and I found one from 1934 to 1942, I think it was. And it's a PDF file. I downloaded it. Sure enough, it has the Model T62. And as luck would have it, it's got a crystal clear schematic in it. Right? This is not a reproduction that's been copied 3,000 times. You can actually read the voltages. See those? So if you have a schematic that you can't read anything on, do a search for a service manual and see if you can find it. So now I know what the schematic is expecting, and I know what I'm going to be reading, and I'm going to document it. Now keep in mind that the set was designed to run at 117 volts. Now the wall voltage is going to be a little bit higher. I am going to make note of the wall voltage before I start testing. This way I know exactly what the differential is going to be, because we know that we can have a 20% differential. So I'm going to go measure the wall voltage, I'm going to measure the voltages in the radio, I'm going to fill them out in these lines here, and I'll come back and show you what we found. One thing I want to show you before you start taking your voltage measurements, make sure that your chassis is secure and it's not going to start flipping and tipping when you're in there. You'll notice what I have here is something underneath the transformer, and I have a spool here in this corner. This thing's not going to go anywhere, it's solid. Make sure you do the same thing on yours. Don't tip these things over on the side and start poking around in there and they fall, and you know what can happen. I think our good friend Terry from D-Lab Electronics likes to put these things in a plastic bin to keep them stable. Whatever works for you, but make sure that it's not rocking around, okay? Let me get to measuring this stuff. Alright, let's see how we did here. So this is our first pass, and you got to remember, you have to do some research here. You have to look at the tube data, the tube charts. So let's see, on the 5Y3 rectifier tube, on pin 8, they're expecting 278 volts, and I have 360.5. That's high. I got to figure that out. On my 6F6, on the cathode, they're expecting 17.8, and I got 15.5. I think that's okay. That's within tolerance. The screen grid, which is pin 4, I got 280 and they're expecting 277, so I'm good there. And the plate, they're expecting 258 and I got 261.8, so I'm good. I think that 6F6 is good. In our 6SQ7, they're expecting 66 volts in the plate and I have 105. That's not good. I need to look into that and do some research. In our 6SK7, they're expecting 278 on the plate and I've got 271. The screen grid, they're expecting 96 and I have 0 on pin 1. I need to look and make sure pin 1 is the right one. I also was poking around while I was in there, and on pin 6 I found 111 volts. So I need to research and see what pin 6 is and see if I've got this wrong. And then lastly, on the 6SA7, on the plate I got 273 when they're expecting 278. Again, on pin 1 I got 0, and I've also found 110 on pin 4. So I need to look at the pinouts on this tube and see if I've got this wrong between pin 4 and 1 and between 6 and 1. So with the exception of these problems here, which I need to research, this is the one that's most concerning. 278, and you remember there's a tolerance of about 20% allowed on this radio. 20% of 278 will bring me up to 333. So we're running a little bit hot. So we may need to have to put a dropping resistor here, but we're not going to do that yet. We're going to make sure we test everything first in the radio and replace resistors and capacitors. And I'll tell you why I'm going that route. Looking at the schematic very closely, let me pull back a little. Well, actually, I'm going to zoom in here real quickly. If we look at our cap setter in here, you'll see right here there's a 0.01, and if we slide over here, you'll see here there's a 0.01, and let's see, here's a 0.0035, and just looking around the rest of the radio, it looks like most of the caps in this radio are 0.01s, or supposed to be 0.01s. And I've confirmed that by looking at the parts list that came in the service manual. And you'll see here that there's capacitors 0.0035, 25, 0.15, 0.5, 0.01, and 0.1s. And if you look inside this radio and zoom back, you'll see here that most of the capacitors in this radio are 0.47s. Here's a 0.47, here's a 0.47, here's a 0.47 over here, this is another one, and the value of this one is I can't read it because it's scratched. So this is a 0.01 here. So the moral of the story is, when this thing was recapped all those years ago, someone put in whatever they had. So this thing is not back to standard factory. So because of that, we are now going to go and recap this thing and put the proper caps inside the radio and see if that makes a difference with our voltages, and then come back. Okay? I am going to end this episode here, and we're going to start off then part 5 with this thing recapped and testing the voltages again, and we'll see where we are. But again, you can't trust what's in these radios. These have the wrong caps in them, according to the schematic anyway. So we now have a baseline. We've got our voltages right here. When I created this chart, I actually saved the blank one so I can print it again and run the same test and do a comparison. And by the way, I was getting 117.5 out of the wall. Okay? So this is going to be pre-recap. We're going to write that on there. When we come back in the next episode, you'll see this be a lot neater under here. Thanks, everybody. Have a great week.